Before refrigeration, before preservatives, before sealed plastic and cold chains, people still managed to keep food edible for months and even years. Not by fighting nature, but by directing it. Ancient societies across Europe, Asia, and parts of Africa relied on a fungal method that did something refrigerators cannot do on their own. It actively protected food from decay. This was not accidental spoilage or blind experimentation. It was a disciplined, inherited system that turned specific fungi into guardians of food. Once you understand how this worked, modern refrigeration starts to look less like progress and more like a temporary workaround. Why ancient people learned that some fungi prevent rot instead of causing it. To modern eyes, mold signals danger. To ancient communities, mold was a language. Through generations of observation, people learned that not all fungal growth behaved the same way. Some molds destroyed food rapidly and caused illness. Others appeared early, spread evenly, smelled clean, and stopped further decay entirely. Those fungi became allies. This realization changed everything. Instead of trying to keep food sterile, which is, honestly, nearly impossible without modern technology, ancient people allowed the right organisms to take over first. Once a protective fungus dominated a food's surface, it prevented harmful bacteria from gaining a foothold. Food didn't rot because the wrong life forms never had a chance. That's how fungal dominance created, a living barrier against spoilage. The effectiveness of this method came from speed and control. When conditions favored a beneficial fungus, it colonized food really rapidly. It consumed oxygen at the surface, altered acidity, and released compounds that suppressed competing microbes. This created a stable environment where decay could not progress. Cured meats coated in white mold, aged cheeses, and fermented grain pastes all worked on this principle. The fungus was not inside destroying the food. Instead, it lived on the surface, acting as armor. Inside, the food remained stable, edible, and often more nutritious than when it started. Why this method depended on environment, not guesswork. Ancient fungal preservation was never random. Temperature, humidity, salt levels, airflow, and cleanliness all mattered. These factors were learned through failure and success over centuries. Certain rooms, caves, cellars, and storage houses were favored because they consistently produced the same results. In many cultures, these environments were guarded carefully. Storage spaces were not scrubbed clean because they held beneficial spores. Tools and vessels were reused specifically to maintain continuity. The preservation system extended beyond the food itself into the architecture and habits of daily life. How fermentation and fungus worked together to stop decay. Fungal preservation rarely worked alone. It was paired with fermentation. Salted, cooked, or dried foods were transformed biologically before storage. Fermentation lowered pH, changed nutrient availability, and made conditions hostile to spoilage bacteria. Fungi then sealed the deal by occupying the surface. This combination explains why, ancient preserved foods were remarkably stable. Fermentation altered the interior. Fungus defended the exterior. Together, they created food that could travel, overwinter, and survive siege conditions without refrigeration. Why warriors and travelers depended on fungal preserved food? Armies just cannot rely on fresh supplies. Ancient fungal preservation made long campaigns possible. Mold-protected cheeses, fermented grain cakes, and cured meats traveled across continents without spoiling. These foods were, compact, calorie-dense, and resistant to contamination. In many cultures, these foods were not considered inferior. They were, in fact, prized. Aged foods symbolize planning, discipline, and survival skill. Losing a fungal culture, well, that meant losing a strategic advantage. So, how did ancient people identify safe fungal growth without science? There were no lab tests or microscopes after all. Knowledge was sensory and communal. Safe molds had predictable color, texture, and smell. Growth was even, not patchy. Odors were sharp or earthy, not putrid. Dangerous growths were recognized quickly and discarded. This knowledge was passed orally and visually. Elders taught younger generations what to accept and what to reject. Mistakes were remembered. Success became tradition. Why modern refrigeration erased this knowledge instead of improving it? Refrigeration stops decay by slowing life. Fungal preservation stopped decay by directing life. When refrigerators became common, biological preservation knowledge faded rapidly. But, refrigeration depends on electricity, infrastructure, and constant operation. Ancient fungal preservation, on the other hand, depended on understanding biology and environment. One system is fragile, the other is resilient. So, the principle here still applies today, even without recreating those ancient risks. Now, understanding this method doesn't mean you should just, casually let food mold. The real lesson is about systems thinking. Stability, in this context, comes from controlling the conditions, not from eliminating life entirely. Modern researchers, historians, and traditional food producers actually study these methods under controlled settings to understand resilience, not to gamble with safety. The main takeaway is a respect for biological processes. Processes that humans once mastered, long before we had any machines. So why does this ancient fungal trick still matter now? Well, in an age of fragile supply chains and heavy technological dependence, the ability to preserve food without refrigeration isn't just primitive knowledge, it's actually strategic knowledge. It really shows how humans once worked with living systems, instead of always trying to overpower them. If you value deep history, survival intelligence, and those overlooked technologies of the past, go ahead and subscribe to Echoes of Valor. Share this with someone who studies history seriously and help keep alive the knowledge that once kept entire civilizations alive.